8.1, we are simplifying rational expressions. Rational expressions just means fractions. All right, but before we get into the algebra problems, I want to go backwards and I want to reduce a simpler fraction like this. And I think most of you would know what to do. What you're going to have to do is say, well, 2 plus 6 right here is 8. And so really what we've got this fraction 6/8. And we can reduce this, and you might know how to reduce this in your head, but why it's going to reduce and do what it is has to do with a common factor. And so we would say something like, well, I know 6 is 2 times 3, and I know 8 is 2 times 4, and we can cancel out that common factor of 2. We can divide both the numerator and the bottom and the denominator by 2, and that's going to leave us with 3/4. So if you were going to reduce that fraction, you would reduce it to 3/4, and that should make perfect sense. 6/8 reduces to 3/4. But what ends up happening, and it's kind of weird, people will try to cancel out this 6, and they'll try to say that it's 1/2. That is absolutely the wrong way to go. That is not going to work. Please, please, please don't do that. All right. In general, I'm going to say you can't cancel out a number that's next to a plus sign or next to a minus sign. But the reason that it's going to happen is the same as this. You knew you had to simplify this 2 plus 6 first. It has to do with order of operations. Order of operations says we're going to have to do whatever this is before we can get to the division. There are parentheses here. And they might not write the parentheses, but they're there. So check this out. If you try to cancel out that 12, every time you do this, every time you try to cancel out this 12, a puppy dies. You can't do this. This is wrong. So please don't kill puppies. All right. You cannot cancel that 12 in this way, in the same way that you could not cancel that 6. I think most people will see it. They're like, oh yeah, that's obvious. You can't do that. But then all of a sudden we get into this problem and they start doing things that can't be done. So let's review real quick. You've got to know how to factor. Factoring is going to be super important. And remember, identifying what type of problem is super important. So I'm not going to do a whole bunch of these, but let's do a few. This first problem is difference of squares. Difference of squares, the square root of 100 is 10. And so we know that factors into m plus 10 and m minus 10. This is going to be important because we're not going to be able to cancel out a number that's next to a plus sign, or in this case, next to a minus sign, but we are going to be able to cancel out things that are next to a multiplication. So when it says like m minus 10, we might be able to cancel that because it's m minus 10 times m plus 10. The next problem, number 2, this is an easy trinomial. Easy trinomial, we said, all right, n squared must have come from n times n. And then we needed 2 numbers that multiplied to 6. And then they're going to add up to -7. So multiply to a positive. That must mean that both of these numbers are negative if they're going to add up to a negative. So we know that -1 and -6 are going to add up to -7. -1, -6, that's -7. So I know these numbers are n-1 and n-6. It's going to be really important that you can factor. All right, so then I look at a problem like number 3. Number 3 just looks weird. When it just looks weird, it probably means there's a GCF. So we look at these, and I assume, I hope all those numbers are divisible by 6. I don't know. They're at least all divisible by 2, I know. And they all have a b in them. But you might want a calculator and say, well, can I divide these numbers by 6? 102 divided by 6. Okay, yeah. And 420 divided by 6. Okay, great. So all 3 of those numbers are divisible by 6 and b. So we would write 6b. And then we would write what you'd have to multiply by to get back to the start. 6b times b squared, plus sign. 6b times, what was it, 17? 17b, plus sign. 6b times 70. And so we factor it like that. But in this case, we've got another, we changed it. This was a GCF, right? We always want there to be a GCF first, but now I see an easy trinomial. And so we see that second pattern. And so we've got this 6b, and we can also factor the easy trinomial now, b into b, two numbers are multiplied to 70 and add up to 17. Well, sometimes that's easy to spot. That's 7 and 10. 7 times 10 is 70. 7 plus 10 is 17. We've got that. So we factored this using a GCF pattern and an easy trinomial pattern. Now we also have a hard trinomial pattern, but anyway, I want to get into the actual problems. So just keep in mind, you're going to have to factor. The reason you're going to have to factor is because you're not going to be able to cancel numbers like 12 and 12. All right, you can't cancel it when it's next to a plus. You can only cancel things that are being multiplied, things that are factors. So when I look at problem number 1, I don't have to worry about that puppy killing thing because there are no pluses. I'm not adding stuff. I just reduce my fraction. Just like I reduced 6/8 to 3/4, I'm going to need to reduce this. Now, in this case, the letters are actually the easy part, because if you look at the letters, x to the 4th means x times x times x times x, and x to the 5th looks like that. Now, you're not going to need to write this down. You should be able to tell, well, we're going to end up canceling out 4 of those x's, and you're going to be left with 1 of the x's on the bottom. So we can see that pretty quickly. Cancel out 4 of these x's is going to leave 1 of the x's on the bottom. To me, the hard part is what you knew how to do in the 6th grade, is reduce the fraction part. So 60 and 48. You need to think about what I can divide both of those numbers by. Well, I can divide them both by 2, and that would give me 30 over 24. But that's not reduced because I can divide both of those by 2. So I divide both of those by 2, and I get 15 over 12. Right? I'm just reducing the fraction. But that's not done either, because I can divide both of those numbers by 3. I can divide both of those numbers by 3. If I divide both those numbers by 3, that would give me 5 and 4. That's reduced. All right. Now, a more efficient way would be what's the common multiple, or what's the greatest common factor, I guess, of 60 and 48. And you could say, well, 60 is 12 times 5, and 48 is 12 times 4. So we can cancel out a 12. There's a faster way of doing it. If you can say, well, I can divide both those numbers by 12, you get a 5 and you get a 4. Now, I've written a lot. You won't need to write all that if you really know what you're doing. Okay, but what you do have to pay attention to is the answer. There's a 5 on the top of that fraction, and there's a 4 and an x on the bottom of that fraction. When it says simplify, in this case, it's talking about reducing the expression, reducing. Okay, so we look at number 3. All right, there's going to be a number of you that try to do this. Okay. Seems like that would make sense, right? M squared, but that's killing a puppy right there. All right, you're not allowed to cancel something next to a plus, and the reason why has to do with order of operations. All right, whatever this is would have to be added together, like that 6 plus 8, or 2 plus 6. I mean, sorry, that 2 plus 6 a minute ago. When I had this problem and we had to add that 2 plus 6 first, it's the same exact concept. So what you're going to need to do is factor. We don't want to cancel something plus. We don't want to cancel something minus. We want to factor. And so you're going to have to identify what pattern it is. The top looks like an easy trinomial. This is an easy trinomial. So we do what we've done before when we factor that. M and M. I need 2 numbers that multiply to 4 and add up to -5. Now, if you can do this quickly, you've got an advantage over people that can't. So if you can do this without writing everything out, that's fine. But I need numbers that multiply to 4 and add up to -5. So it's going to be -4 and -1, right? -1 and -4. It doesn't matter which order you do. So I just took the top, and what I wrote down there is the same thing as the top. It's just in factored form now. And the advantage is I can cancel my factors. I can cancel factors. I can't cancel the m squared, but I could cancel an m minus 1 maybe. So now let's look at the bottom. The bottom, we're going to do the same thing. The bottom is also an easy trinomial. So treat it like an easy trinomial. M times m gave me the m squared. I need two numbers to multiply to -5 and add up to +4. So there's only one possible combination of numbers. It has to be a 1 and a 5. Now remember, you've got to multiply to a -5, so that means one of the numbers is negative. Which one? Right, -1, that's the negative one, and +5. So -1 and +5. It doesn't really matter what order you write those in, as long as you have m minus 1 and m plus 5. You can switch them around backwards, it doesn't matter. But now here's the thing. We're trying to simplify. That's the directions. And it's important to notice that it's this times this. We can cancel something that's being multiplied. So in this case, since it's m minus 1 times something and m minus 1 times something, we can cancel that out. And what we're left with is m minus 4 over m plus 5. Now, can I go on and cancel those m's? I can't, because it's not an m, it's really m plus 5. It's a m minus 4. There's not a factor of m to be canceled. So there's nothing else to do. That's finished. All right? That's a basic example. That's probably the most important one. Now we're just going to kind of iterate here. Number 5, we're trying to cancel. And again, what people are going to do, probably incorrectly, is they're going to say, well, 18 and 9 cancels, and that's 2. But that's wrong. Don't write that down. That is wrong. You cannot cancel that thing that's next to a minus. What you're going to have to do is factor. So what you want to do is say, well, this looks like a GCF problem. Oops. This looks like a GCF problem. What's in common of the 2x and the 18? What can they both be divided by? 2 and 18. Both of those can be divided by 2. So the common factor is 2. And then you think about what would I multiply by to get back to 2x minus 18? Well, 2 times x and minus 9, right? I've just factored. Factored means write it as a multiplication problem, right? I've got 2 times x minus 9. Well, this one's pretty much done because I've got an x minus 9, which could completely cancel with that x minus 9 right there. All I've got left is a 2 on the top of a fraction. Now, you could say 2 over 1 if you want, but that's not necessary because 2 over 1 reduces to just 2. So we're trying to reduce. We're trying to get the smallest, simplest form of the answer, and that is 2. All right. Now we're rolling. There's nothing to do on the top, but the bottom you need to say, well, that's an easy trinomial. So I'm going to factor that like it's an easy trinomial. In and in. 2 numbers multiplied to -60 and add to +4. If you're good at this, maybe you can just kind of think it through and not write this down. But I find that if you sit there and think about it for more than like 2 or 3 seconds, write it down. Okay. If you can think of it in a second or two, go for it. But if you can't, if you haven't thought of it yet, then write this down. 1 and 60, 2 and 30, 3 and 20, 4 and 15, 5 and 12, 6 and 10, 7, 8, 9 don't work. So what are we looking at? We got to multiply to a negative, so that means one of my numbers is negative. -6 and +10. Very good. And you know what? It makes sense that it's -6. You know why? Now we can cancel n minus 6 with n minus 6. Now, be careful. You're left with n plus 10, but you have to pay real close attention to where it is. See how it's on the bottom of a fraction? Make sure you put it on the bottom of a fraction. So what's on the top of the fraction then? 1, right? It's just like if we reduced a fraction like 2/4, 2 goes into 4 twice. You don't say that answer is 2. You say that answer is 2 on the bottom. That reduces to 1/2. It's the same exact concept, all right? The top canceled out, so you're going to be left with 1. N minus 6 divided by n minus 6 is 1. All right, now, Number 9 all of a sudden looks way, way, way more complicated. But remember what I said. When it looks complicated, it's probably going to be a GCF. GCF. Oops. GCF. What do all 3 of those things have in common there on the top? They all have a P in them, right? All 3 of them have at least a P on the top. So I see a P there. And then that'd be P squared minus 14P plus 48. If I took a GCF of P out of there. All right. But you might notice that top has just turned into an easy trinomial. So now we can also factor the top using an easy trinomial pattern. Okay. So we've got that P in the front, but then it's going to change into P and P. And we need 2 numbers that multiply to 48 and add up to 14 somehow, add or subtract. Okay. So again, if you can think of the numbers, great, go for it. If it takes you more than 2 or 3 seconds, then I think it's probably best to write it down. 48. That's 1 and 48, 2 and 24, 3 and 16, 4 and 12, 5 doesn't work, 6 and 8, 7 doesn't work, done. Okay, so you need to come up with the numbers that are going to make 14 out of that. Usually when I write it down, I immediately see it. If I can't see it, if I don't know what it is, I write this down, I'm like, yeah, it's got to be 6 and 8. That's the only way to make the 14. I know it multiplies to a positive 48, but in order to add up to negative 14, both of those numbers must be negative. So I'm looking at P minus 6 and P minus 8. I like to write the problem like this. I like to just kind of scratch it once and write my next step above. I think that's the most efficient use of the time of the space. If you want to rewrite, go for it. I think this is just a little bit more efficient. So now we look at the bottom, and the bottom looks complicated, and so I'd like for there to be a GCF. That's what you want to look for first. This looks like a hard trinomial, but you could do a hard trinomial, but it's actually easier if you notice there's a GCF. All 3 of those numbers are divisible by 3. So sometimes if you take a GCF out, you'll turn a hard trinomial into an easy trinomial. 3, okay, times P squared plus 2P minus 3 times what would give me 240? What? 80. Yes, correct. Okay. At which point, it looks like I produced an easy trinomial, right? So I've just changed my GCF problem into an easy trinomial problem. So I've got the 3 in the front, and now I'm going to do an easy trinomial again. I need 2 numbers that multiply to negative 80 and add up to positive 2. So again, sometimes you can just see the numbers. You see them? 8 and 10 is going to work, right? If it takes you longer than a couple of seconds, write it down. But this one, you're like, well, it's got to be 8 and 10. Which one's positive and which one's negative? 8 is negative. Negative 8 and plus 10. Okay, cool. That does the trick. Those 2 numbers multiply to negative 80 and add up to positive 2. You've got to do both of those things. And so now you got to kind of step back and see if there's anything that can be canceled out. P minus 8 can cancel out. Correct. P minus 8, P minus 8. But nothing else. Nothing else cancels in this problem. So on the top, I had P times P minus 6. And on the bottom, I've got 3 times P plus 10. Occasionally, you'll see people distribute that back. I don't worry about that. I would just leave it alone. I would leave it like that. Now, number 11, all of a sudden this looks a lot harder, but this is actually the easiest problem we've seen so far. Because everything is factored already. All right, everything is factored already. You could even look at this as x plus 2 is a factor in parentheses and x plus 10 is a factor in parentheses. You've got everything factored to where you need, and it doesn't matter if it doesn't really matter where it is, left or right. It matters if it's top and bottom. So you see how there's an x plus 2 here? I can cancel that x plus 2. And see how there's an x plus 10 here? I can cancel that as well. And so if you wanted to rewrite, what you've got is 4 on top and 2x on the bottom. But you should also notice one more thing is going to cancel out. And maybe you would have noticed it at the beginning. 2 goes into 4 2 times. Or 2 goes into 4 2 times. You're going to end up with a 2 on the top and an x on the bottom. That's the answer. That's the simplified answer. When they say simplify, they mean cancel out the common factors. All right, now on the back. Problem looks pretty complicated, but one thing that's kind of nice, I guess, I noticed that this and this are the same. It doesn't matter that one's on the left side and one's on the right side. What matters is one's on the top and one's on the bottom. Those two things are going to cancel out. So even though we could do a GCF with that, I don't want to because I don't have to. You could do a GCF on those, but they already are the same. They're common factors already. They'll cancel out. And so if you want to clean this up, I'm looking at 3p squared minus 15p on top of a 6. Again, it doesn't matter that one's on the left and one's on the right. What matters is one's on the top and one's on the bottom. But doesn't that look like a GCF right there? That's a GCF. What can I divide out of both? What is common to both of those terms? A 3 and a p. Very good. So then we're going to write down what would I have to multiply by to get back to 3p squared minus 15p? P minus 5. Very good. And so now I do see one other thing that I could cancel out. You see how this 3 will go into this 6 twice? 3 goes into 6 twice. I can reduce that part of the fraction. Notice the 2 is on the bottom. The 2 will end up on the bottom. So I'm going to have a p times a p minus 5 over 2. That's my answer. Okay. Problem 15 is kind of nice because it's already factored. You should be able to notice that those x minus 6s or x plus 6s are going to cancel out. X plus 6, boom, done, gone. All right. But the x plus 4 is also going to cancel out, but there's something kind of tricky that happens. X plus 4 squared means it happens twice. X plus 4 times x plus 4. And you don't need to rewrite it like that. But you do need to notice that there's 2 of them on top. And so if you're going to cancel an x plus 4, there's still going to be another x plus 4 left over. All right, we've got that x plus 4 left over. One of them anyway. One of them canceled, one of them's left. I've got x plus 4 over 4. Now, can I cancel those 4s? I cannot cancel those 4s. Remember, if you do this, a puppy's going to die. Okay? You can't do that. You cannot cancel that 4. Please don't. That x plus 4 is its own thing. X plus 4 has parentheses around it. X plus 4 is the factor. This is actually finished. Okay. Next one. I don't see anything that cancels out, but what I do see is a whole bunch of GCFs. So this top left thing, both of those numbers are divisible by 7. It's 7 times 5r minus 3. That was a GCF. Okay, on the bottom, I don't have a GCF on 5r minus 3, but I see another 5r minus 3 that's going to cancel. So that's kind of nice. Look at the top right, 15 and 30. Well, both of those are divisible by 5. That's true, but there's something bigger. We want the greatest common factor, not just any common factor. Both of those are divisible by 15. Very good. So 15 times r minus 2. And you would recognize it if you said 5. If you said 5 and you wrote down 5 and you said 5 times 3r minus 6, You should recognize that 3 and 6 still have another common factor. 3 and 6 are still both divisible by 3. So that, even though that would be technically kind of right, it's not the greatest common factor. We look at the bottom right over here. Both of those numbers are divisible by 21. And you get r minus 2. So lots of common factors there. And we can see some stuff that cancels out. I've got a 5r minus 3 going to cancel a 5r minus 3. I've got a r minus 2 going to cancel an r minus 2. So if you clean up, and I wouldn't at this point, but if you did, you would see a 7 times 15 over 21. That's all we've got left, but I see one more thing that can cancel. One more thing that can reduce. 7 goes into 21 3 times, right? And so I'm at 15 over 3. Oh, but one more thing happens. 3 goes into 15 5 times, right? We've got 5. That answer, all that stuff turns into just 5. Now division. People don't like dividing fractions just because they can't remember one little thing. When you divide fractions, you always are going to have to multiply by the reciprocal. All right, and you know this, and you probably remember this, but everybody forgets it. When you divide fractions, you have to multiply by the reciprocal. So what I would do probably is just like change this problem to times the reciprocal. So just change the problem, times the reciprocal. Okay, and then just do what we've been doing. Do the exact same stuff that we've been doing. Okay, so notice 3 of these x's are going to cancel with 3 of these x's and leave you just 1 x. That's how it works. Do you see something else that cancels? 5 goes into 10 twice. Okay, so I probably would skip this step, but if you look at what we have on the top now, we have 7 times 2x over 9. I'd probably skip this step and go straight to the end and multiply 7 times 2. 7 times 2 is 14. So I've got 14x on the top. I've got 9 on the bottom. There's nothing else to do there. Okay, 21. We're still dividing fractions, so check out what I'm going to do. I'm going to change this to times the reciprocal. Divide is times the reciprocal. So just flip it. Flip the second one, not the first one, the second one. Times the reciprocal. All I did was flip it. And I'm gonna reduce this the same way. You see how we've got an easy trinomial? Let's do an easy trinomial there. A and A. I need 2 numbers to multiply to negative 50 and add up to negative 5. Anybody see the numbers? Okay, that's fine. If you don't see them, then you write it down. 1 and 50, 2 and 25, 3 doesn't work, 4 doesn't work, 5 and 10. It's going to be 5 and 10. A lot of times, as soon as you see it, you're like, yeah, it's got to be that. It's got to be positive 5 and negative 10, plus 5 and negative 10 in order to make the numbers work. Bottom left, that's a GCF. There's a 3 in common. Take out 3, you're left with A plus 5. That's good because you can see how something's going to cancel out. Bottom right, that's another easy trinomial. So A and A, 2 numbers that multiply to 40 and add up to 6 or subtract. If you don't immediately see it, write it down. 3 doesn't work, 4 and 10. 4 and 10, right? 5 and 8. It's going to be 4 and 10. Specifically, it's going to be what? Negative 10? and positive 4, minus 10 and positive 4. Boom. Okay. So I've got a lot of stuff going on there. But just keep track of what's on top and what's on bottom. There's an a plus 5 on the top, cancel with an a plus 5 on the bottom. There's an a minus 10 on the top, cancels with an a minus 10 on the bottom. There's one other thing. This 3 is going to cancel with this 3. And so literally all that's left is a plus 4, but you've got to pay attention to where it is. See how that a plus 4 is on the bottom? Make sure your a plus 4 is on the bottom. What's on the top then? Just 1. 1 over a plus 4. That's a good problem. That's a good one. Okay, 2 more. Next one. Change it to times the reciprocal. Times the reciprocal. And I don't know, man. Does anything cancel? I don't see anything that cancels. This is a weird one. Nothing cancels out. So we can just multiply. Look at the top. 9 times 7 is 63. X squared times x squared. Those do not cancel because one of them's on the top and the other one's on the top. They're gonna combine. And so x squared is x to the 4th. There are actually 1, 2, 3, 4 x's on the top now. On the bottom, 4 times 10 is 40. That was a weird one because nothing canceled out, but that's fine. Last problem, number 25. First step here, multiply by the reciprocal. Division. Don't do that on multiplication. Only do that on division. We went through like 7 problems or something where we never did this. All of a sudden now we're doing it because it's division. Multiply by the reciprocal. And probably going to see some GCFs. I think your big clue that it's a GCF is when it looks difficult. If it looks really complicated and weird and difficult, it's probably a GCF. So I look at these two numbers. They're both divisible by 4. And I've got an n, so 4n. 4n times 7n is 28n squared, plus sign. 4n times 2 gives me 8n. There we go. That's the top. So you can notice already that those 4n's are going to cancel. But now I look at the bottom. Look at the bottom, and I've got a GCF. Both of those numbers are divisible by 3. And they both have at least 2 n's in them. So I'm going to say 3n squared this time. 3n squared. And so then 3n squared times 7n is 21n cubed, plus sign. 3n squared times 2 would give me 6n squared, and that's my GCF. And then you're thinking, well, okay, great. We've got a 7n plus 2 that's going to cancel out. I know there's a lot going on. It makes your eyes go cross sometimes. There's so much stuff. So just pay attention to what's on top and what's on the bottom. I'm looking at a 6 on the top and a 3n squared on the bottom. Is there one more thing that we can cancel? 3 goes into 6. How many times? 2 times, and notice it would be on the top. That's going to be a 2 on the top. So my answer is 2 over n squared. Done.